Hello, good morning everyone. Today I would like to share with you a topic on discrete convolution. This is the chapter outline. In this chapter, we'll cover the convolution process, analytical evaluation of discrete convolution property, convolution of finite sequence, property convolution, and discrete correlation. First of all, what is convolution? Convolution is when you pass a signal through a system, you can characterize it in a frequency domain or a time domain. The process you get is called convolution. For example, the input xt, and you also have the system of the ht, and then the output is the convolution of the input and the system. So yt equal to xt convolute with the ht. After you know what is convolution, but what is the application of convolution? Convolution are found in many, convolution and related operations are found in many applications of engineering and mathematics. For example, in electrical engineering, the convolution of one function with the second function representing the response of a LTI system. And the strong impulse give the system's output. So convolution is also a central concept in relating the time and frequency domain. In digital signal processing, discrete time convolution is a method of finding the zero-step response of the relaxed LTI system, in which we have to fulfill the unity and time invariant. LTI system is if time invariant. Okay, time invariant if the form of its impulse response does not depend on the time that the impulse is applied. Or we can say there is no difference in time. Assume that the system information is known in terms of impulse response. We call it Hn. And if the input is delta n, a unit sample at the origin n equals 0, the system response is Hn. This can be illustrated in this example. Okay, delta n is the impulse unit and Hn is the system impulse response. Or we call it as a trend of impulse response. Okay, you have the input like this, delta n, and then you have the system impulse response, xn, in which I have 4. Okay, if we illustrate in a diagram, I have the input, and then I pass through a system, and then I get the output. So this input will be the delta n, and then the system impulse response is the Hn. Okay, and then the output is x0. x0 is referred to here, the amplitude of x0, and you have multiply with the Hn, the system response. So x0 from here you get 4 Hn. Okay, now we go to another one, shifting properties. Say I have a delta n minus 1. So this is at location 1. And then I have the xn. At location 1, I have 4. Okay, if you illustrate in the broad diagram, it will be like this. So this is the input, and then this is system, and then this is output. For the input, is a delta n minus 1. Okay, system hash n. And then the output is here, x1 at the location 1, hash n minus 1. So x1 is, the value is 4, hash n minus 1. Okay? Now we go back to slide. Okay, as I told you just now, you have the input and then the system response, or we call it system impulse response, and then you have the output. And somehow the impulse response may have the initial condition. Is either zero step response or zero input response. If zero step response means that the initial value is 0, so it depends fully on the input value only. If zero input response, this means that the input is 0 and only depends on the initial value or initial step. So if the input is x0, okay, at the origin, del n multiplied with del n, a scale impulse at the origin, the response is x0 hash n. This one is I just show you just now. We name it as a linearity. And then if the input is a shifted impulse, x1 del n minus 1, in which the n is at 1, so the response is x1 hash n minus 1. This one we call time invariant. Therefore, we can say that the response to the shifted impulse is xk del n minus k at n equal to k. So we can write in this one xk hash n minus k, input and the multiply with the impulse response. Sn, we know that Sn is a sequence of samples, so it can be write like this. Sn equal to a summation of the xk delta n minus k. The front part, okay, we call it sum of the scale. So this is the summation of the scale, and this is a shifted impulse. By superposition, the response of xn, the response of xn means is yn, is the sum of the scale and the shifted version of the impulse response. It's the same like just now, the summation of the xk hash n minus k. Okay, xk multiplied with n minus k, or xn convolute, this is a symbol of convolution, xn convolute with the hash n. So this one, we call it as a linear convolution. And the expression of computing the yn, we name it as a convolution sum. The argument of the x and hash can be interchanged without affecting the result. This means that just now is the, okay, you go back to just now, is xk hash n minus k. Now I said that x n minus k hash k, or we can say it as a hash n convolute with the xn. It is the same. There's no effect on the result. Next is the analytical evaluation of the discrete convolution. So the procedure of the analytical convolution can be implemented if the xn and hn are described by a simple analytical expression. So in this convolution, we usually see the uk and un minus k. Okay, we always involve this function uk and un minus k. But what is this? What do you know about this, and how to draw this uk and un minus k? Okay, let me show you. Let's say we have UK equal to 1, 1, 1, 1, 1 up to infinity, and origin at n equals 0. So when you draw a diagram, so it will be looked at this 1, 1, 1, 1. So this is up to infinity. Okay, what about, this is UK. What about U minus K? So it means that it's a mirror version. It is from 1 to negative infinity, right? So it's U n minus K. It's negative infinity. Okay. 1 to negative infinity. If you draw a diagram, it will be looked like this. Okay. Now you know UK and U minus K. So what do you know about U n minus K? U n minus K is U minus n plus K. So it's still equal to n plus K, n minus K. So n minus K, I can rewrite into U minus the bracket minus n plus K. Yes, minus n plus K. Or I can write it like U minus K plus N. So if you look at this, minus K plus N, okay, is this one actually, it is like a shifting. It's like a shifting. And this one is like a folding. Okay. So we can draw, okay, or we can illustrate this minus K plus N into like this. Okay, assume this one is N. This one is to negative infinity because it's a negative K. If we look at this one, negative K is 0 to infinity, minus infinity. Now it's minus K plus N, means that it's starting from N to negative infinity. Now look at the example. Let the xn equal to hn and equal to un. Then xk equal to uk and hn minus k equal to un minus k. Then calculate the output. So in order to solve this one, we need to define the uk first. Okay, uk is this one from 0 to infinity. And then the second, define u n minus k. So n minus k, I already told you, is from n to negative infinity. And then number 3, step 3, product uk and un minus k. Okay, you product, what do you get? Probably I redraw the un minus k into a same axis. Okay, so you product these two product. UK multiply with UN minus K. So what do you get? So alpha K equal to 1 minus alpha n minus n plus 1 divided by 1 minus alpha. This is when alpha is equal or not equal to 1. And then also equal to n plus 1 when alpha equal to 1. So based on this finite sum table, we say that this summation from 0 to n is n plus 1 un. This one also equivalent to r n plus 1. This is also a property. Now look at another example. Let the xn equal to 0.8 power of n u n minus 1 and the hash n equal to 0.4 n un. Then find the convolution. Do you still remember what is the convolution formula? Okay, this is the convolution. Okay, convolution formula yn equal to summation of the xn hash n minus k equal to xn hash n. So just now the question is find their convolution. So this means this one. The question given the xn and the hash n. So you do the convolution. And the convolution also equal to the summation of the xk hash n minus k. This means that you need to change the n equal to k. And for the part of the hash n, this one, you change the n to n minus k. Okay, now let's go to do it together. Okay, so you know this formula. Summation k minus infinity to infinity xk hash n minus k. Okay, just now I told you you change the n to k. Okay, this one from the formula here, you know that this is the xk and hash n minus k. But in the question only have the xn. So you change the n in xn to k. And change the n in hash n to n minus k. So you need to follow the formula. Formula says xk, so the n in the xn you change to k. And then for the hash n minus k, what you have only hash n. So you change the n in the hash n to n minus k. This is that you need to know. Okay, so now, so yn equal to summation k from minus infinity to infinity xk. So now xk is what is the value? 0.8, right? Based on the question. So 0.8, the n changed to the k, right? Okay, u k minus 1. And then time with multiply with the hash n minus k. So you have for the hash n minus k, you have 0.4 power of, okay, this one power of n, right? If you look at this one, and this one, so all change to n minus k. This one also same, n minus k. So now you have 0.4 power of n minus k. This one also the same, u n minus k. Okay, now from the question, you have this unit step function. You need to solve this in order to get the limits. Okay, how? You draw the graph. Okay, u k minus 1. This means that k equal to 1 until infinity. The value is 0. And then for the n minus k, still remember, for n minus k, the value is n to negative infinity. The value is still 1. So these two you product. Okay, you multiply it. Then what do you get? So for the u k n minus 1, the value starting from 0 to positive infinity. For u n minus k, the value is from n to negative infinity. So the overlapping, when you product only the value from here, you have the value. Means that this one is 1 for u n k minus k. Multiply with here also 1. So 1 times 1, you get 1. For this one, you multiply, you also get 1. You multiply this one, you also get 1 this. You multiply this one and this one, you get 1. This one and this one, you get 1. Okay, so up to n. Okay, so for below the 0 value, this one all are 0. So 0 multiply with 1, you get 0, all 0. So, okay, you see that, oh, so this one, the value here is 0, okay, because k minus 1 means that the value starting from 1. So the value here is 0. So 0 multiply with 1, you get 0. Okay. So the limits is from 1 to n. Now, you know the limits. So let's continue. Instead of summations from minus infinity to infinity, now you can say that it's from 1 to n. Okay, from 1 to n. And then you continue the value just now. You have 0.8 power of k and 0.4 power of n minus k. So 0.8 k and then 0.4 n minus k. And the summation, the product of these two graphs will result in this one, limits, and the value amplitude is 1. Okay, amplitude is 1. So now you can simplify. Zero 0.8k, 0.4 minus k, and then 0.4 power of n. So 0.4 power of n actually is a constant. So you can take it out. 0.4 power of n. So now you have 0.4 power of n. Summation k from 1 to n, 0.8 divided by 0.4. Because minus k, you bring the k to down, so it's divide 0.4. So this one will result in 0.8 divided by 0.4. You get 2. Sorry, I have k here. I have 2k. So how to solve this one? So you can refer to the finite sum table. This is the useful mathematical relation. And in this mathematical relation, in this table, we have the finite sum table. So you can go to look for the same equation. For example, in your case, okay, which one is more suitable or similar to your case? We can use this one. Summation from from 0 to n alpha k. Yours is 2k. So here is alpha k, so we can use this one. If you look at the alpha here, alpha not equal to 1 or alpha equal to 1. Yours is 2 power of k, so alpha is not equal to 1. So you can use this formula. 1 minus alpha power of n plus 1 divided by 1 minus alpha. Okay, if you check properly, this formula or this equation is starting from 0 to n, and your case is 1 to n. Okay, so you must do something because this is the limit of table. This formula only used for 0 to n, but yours is 1 to n. This means that you need to delete. Okay, you need to delete. So I draw a limit here. Say this is 0 and this is 1 and this is n. Okay. Now in your formula this is the limits in table. Okay, 0 to n. But what you want is 1 to n. So this is I name it as a required limits. So means that you have the extra from 0 to 1. So this one you need to delete it. You need to delete. So k from 0 to n, this is the limits of the equation. And then you minus with k from 0 to 0. This is what you want to delete here. Okay. So now you have 0.4 power of n. summation k from 0 to n to power of k minus 0.4 power of n. The k is from 0 to 0 to power of k. Now you can simplify. 1 minus, so just now the equation is 1 minus alpha, this one. 1 minus alpha n plus 1 divided by 1 minus alpha. So 1 minus alpha, alpha is 2. So 1 minus 2 power of n plus 1 divided by 1 minus 2. Minus with 0.4 power of n, and then k is 2 power of 0. So 2 power of 0, you get 1. So 0.4 power of n, 1 minus 2, n plus 1 divided by minus 1, and then minus with 0.4 power of n. Okay. Next, 0.4 power of n. So I separate it, so I get negative 1 plus 2 power of n plus 1 minus 1, because I take out the 0.4 here. 0.4n, 0.4n, so I factorize it. I take it out. So 0.4 power of n, this one, if I want to change it, so I can have the 2 power of n for this part, and then time with 2 power of 1, minus 1 and minus 1, you get minus 2. So what do you get? You multiply in this one and this one, you get 2, 0.8 power of n, so this one and this one, so 0.8 power of n, minus with 2, 0.4 power of n. Okay, and then you need to write the unit. What is the unit? How to determine the unit? Here I show you some tips how to find the unit. Now the limit is from 1 to n, right? Okay, so now limits, let me write it here, limits is from 1 to n. And then if based on the table, okay, this one, k is equal to 0 is fixed. Okay, but how to get k equal to 0? Okay, for example, I have the, like this, I have 0 and 1, I have the n here, and I have the n plus 1, n minus 1, n minus 2, something like this. Okay, so the limits for your equation or for your answer is from 1 to n. Okay, but the k equal to 0 is fixed. Okay, so what do you want? What you have to do? So you need to shift this one to the left 1 unit. So of course, when you shift this whole thing to the left, so it's starting like this. This one, it means that you also shift 1 unit to the left. So now the unit is from u n minus 1, because you already shift here. It's a unit step un, right? But because of the table, starting from 0 to n. Okay, so you shift shift to un. But how to get k equals 0? How I want to shift to get 0 here. So you shift 1 unit to the left to get n equals 0. So of course, this un also shift to the left 1 unit. So you have un minus 1. Okay, that's all for this convolution example. Hope you can enjoy the video. And if you like my video, please like my video. Thank you and enjoy watching.